Oh, didn't see you guys there. Welcome back, Mr. Munyon here. We're going to be working on activity 15-2, trapezoids. So let's go ahead. All right. In activity 15, our goal is to develop properties of trapezoids and prove some. We're going to focus on developing those properties, not necessarily proving them. We just need to develop them and use them. So the trapezoid is a quadrilateral with exactly one pair of parallel sides. Hopefully you guys learned about trapezoids in middle school before. That has parallel sides are called the bases. So on the right, I have an example of a trapezoid, more like probably what you're familiar with, and I can see the top and bottom pieces are parallel, so that's why we know it's a trapezoid. The non-parallel pieces, like this left side and this right side, would be called the legs. So the parallel pieces are the bases, the top and bottom of this one would be the bases, and the left and right side would be the legs. However, any quadrilateral that has one pair, only one pair of parallel sides, is a trapezoid. So this figure down here has a left and a right side that are parallel. So this is a more uncommon shape of a trapezoid. Trapezoid nonetheless because it meets the definition. Let's go ahead and sketch a trapezoid, label the pieces T, R, A, P. Here it says identify the bases, the legs, and both pairs of base angles. Okay, so the bases would be the parallel pieces. The bases are TR and AP. The legs would be the other two pieces here, so RA and TP. And then the base angles, there's a pair of angles on this base, so base angles. They kind of go together, so T and R go together, and the other pair would be angle A and P. Okay, now that we've identified the parts, let's talk about the median of a trapezoid. So a median of a trapezoid is a lot like a mid-segment of a triangle in that it connects two midpoints of the legs of a trapezoid. So the median of a trapezoid is also parallel to its bases, and its length is the average of the two bases. So remember, we just learned about that when you have a mid-segment, connect a midpoint and midpoint, you get this, that this piece here is parallel and it is 1/2 of that third side of the triangle. Well, these are all going to be parallel to each other. The mid-segment, or the median, is parallel to the bases, and it's 1/2 of the sum of these two bases here. So your average, when you do 1/2 of the sum of two things, that's actually just an average. So in reality, we're just averaging the two parallel bases to find the median of a trapezoid. A way to think about this is to think of it as two separate triangles. So like right here, if I drew this diagonal, this creates a triangle GEH, and it also creates a triangle FGE. And each one of these has its own little mid-segment. So from here, the blue line that I drew over to N, that's a mid-segment of that triangle. It's half of this base, EH, and the other half over here is a mid-segment with a base of FG. So this mid-segment here is going to be half of this base. So together, it's half of this base and this base. So that's literally where the formula comes from. Is you can think of it in terms of mid-segment of triangles. We've already proven. We're not going to go through the proof of that. We're just going to practice it. All right, so given we have trapezoid EFGH and MN is a median, use the figure here. I went ahead and put it on this page for the properties of trapezoids and or the trapezoid median theorem. If the measure of angle GFE is 42, so GFE, that would be this one here, is 42 degrees, then the measure of angle NME equals what? Well, because this is a median, I know these are parallel to each other. So this is parallel lines cut by the transversal here. These are corresponding angles. This will also be 42 degrees. So angle NME, so NME, this angle here is also 42 degrees. All right. What about MEH? Okay, so how do we figure out MEH, this angle down here? Well, this is now parallel lines cut by a transversal. We have same side interior angles, which are supplementary. Just by looking, I can see this is obtuse, this is acute, so they're not congruent. So 180 minus 42 equals 138. If we did set up an equation that says 42 plus x equals 180, that's a supplementary angles. So subtract 42 from both sides, we get 138 degrees. I guess I should have put degree markers on there. All right, for part B, it says write an equation and solve for x if, all right, I'm going to erase what we have over there and relabel some more things. So FG equals 4x plus 4. EH equals x plus 5. And MN equals 22. All right. This one is a little bit more challenging, but what we just learned is that the median of a trapezoid is going to be the average of the two bases. So all I need to do is add up the two bases and divide by 2, and I'll find the median. Even if it's algebra expressions, I know that MN is going to equal 1/2 of the sum of the two bases, FG plus EH. So I should be able to substitute in here MN equals 22. 4x plus 4, I'll go ahead and add those right now. So I'm adding these two together, so 5x plus 9. If I multiply both sides by 2, I get 44 equals, and multiplying by 2 here just cancels out the 1/2, 5x plus 9. Subtract 9 from both sides. Divide by 5, we get x equals 7. So I have found out that x equals 7. And if you're not sure if you did this algebra correctly, you can obviously plug it back in just to make sure that 22 is the average of these values. So 7 plus 5, we do get 12 here. And 7 times 4 is 28, plus 4 is 32. If I add these two pieces together, I get 44. Half of 44 is 22. So checking my work, it does verify that I did correctly find the median of that trapezoid. All right, let's keep on moving along. Now's a good time to check our understanding. Try number 5 and 6. Pause the video here, and I'll start it back up in just a moment with the answers. All right, now that you've had a chance to look at 5 and 6, it says, how does a trapezoid differ from a kite? Well, the definition of a trapezoid is a quadrilateral that has one pair of parallel sides. A kite does not have any parallel sides, so that's the easiest explanation there. Kite does not have any parallel sides. All right, this little parallelogram off here to the side, I actually put over here just for question number 6. It says, can a trapezoid have bases that are congruent to each other? So I tried to draw a trapezoid that has bases that are congruent, and it looks like a parallelogram. And notice if I tried to stretch out the top side here, the bottom side, let's say the top and bottom pieces are the parallel pieces. So let's say I stretch out the top and bottom so that they're still congruent in length. Notice what happens. The other two sides make it stay as a parallelogram. Same thing here. What if I keep the top and bottom congruent and try and move this around here? Doesn't matter what you do. If those are congruent pieces, the endpoints are still going to connect at the exact same slope if it was on a coordinate plane. So these other two sides are also going to be parallelogram. No, if you had a parallelogram that had congruent bases, if you had a trapezoid that had congruent bases, it would be a parallelogram. Let's now look at the isosceles trapezoid. What does that mean? So if you think about isosceles triangles, we know that an isosceles triangle has two congruent legs. So maybe that means the same thing. A trapezoid has legs. Maybe that's all it means is the legs are congruent to each other. So an isosceles trapezoid with congruent legs. Given triangle ABC is isosceles. So I know that this whole side here is congruent to this whole side here. We also know that AB, we already labeled that one, AB is congruent to CB, and that AD here is congruent to CE. Okay. It says angle A is congruent to what, and explain. Okay, well, angle A would be congruent to angle C because first thing we know is an isosceles triangle has congruent base angles. If you have two congruent sides, you're going to have two congruent base angles. So angle A is congruent to angle C by the isosceles triangle theorem. If you have two congruent sides, you have two congruent angles. It's actually the side angle theorem. Next one says explain why triangle BDE is isosceles. So the smaller triangle BDE, why is it isosceles? Well, if you have originally the entire sides are congruent here and you take off the same amount, what's going to be left is the same amount on each side. So segmented. Obviously abbreviating a little bit here. But the next one says AC is parallel to what? So AC is parallel to, I can see here, segment DE is what it looks like it's parallel to. How do I know that? Well, because if these two triangles are both isosceles triangles with the same angle, that means that they're similar to each other. They both have the exact same angle measurements. It's just a smaller version. So that means this angle right here has to be congruent to this one because those are corresponding angles on lines that I've proven parallel. On parallel line cut by a transversal BA, I know that those have to be parallel to each other. So DE, and that's because of the converse of the corresponding angle theorem. And then explain why this is now an isosceles trapezoid. So by definition, it has one pair of parallel sides and the legs are congruent. So then angle ADE, ADE would be the other. I'm going to use a different color here. Maybe we can use red. So ADE has to be congruent to CED. And we could explain that in a couple of different ways, but I think the easiest way is just to say on this isosceles triangle, you have two congruent sides, so you have two congruent angles, and both of these red angles I drew down here are supplementary. So we could say because they're supplement to congruent angles. So CED. So those two red angles are both supplementary to those two green angles right above them. Those two congruent angles. All right. So then on the next page it says complete the theorem. The base angles of an isosceles trapezoid are congruent. So notice on this isosceles trapezoid, I'm going to get rid of all this extra writing that we had on here to focus on just this part. We have an isosceles trapezoid here. The base angles here are congruent on the base AC. And then on the other base, DE, these two base angles will be congruent to each other as well. I do want to point out angle A is not congruent to D, and you can tell just by looking. This is an acute angle for A, this is an obtuse angle for D, but there are two pairs of congruent base angles. All right, let's look now at question number 8. On grid paper, plot quadrilateral COLD with these coordinates. I've gone ahead and done that over here on the side. We've got these coordinates 1, 0, O is 2, 2, L is 5, 3, D is at 7, 2. Show that this quadrilateral COLD is a trapezoid. So definition of trapezoid has 4 sides. Count, it's got 4 sides. and it has one pair of sides that's parallel. Looks like OL and CD are parallel, so we should be able to do that by finding the slope. So the slope of OL equals rise of 1, run of 3. So, and the slope of CD, rise of 1, 2, run of 1, 2, 3, 4, 5, 6. So simplify that, we get 1/3. So we do have the same slope. So that tells us these lines are parallel. So it is a trapezoid. All right, next part asks us to show that this is isosceles. So to do this one, we would need to find the length of the two legs and make sure that they're congruent. So the two legs then would be CO and LD. So CO equals, distance formula is change in x squared plus change in y squared. So here we get change in x is 1, change in y is 2. So 2 squared is 4, plus 1 is 5. I get square root of 5 for that distance. On the other one, I'm going to save some time because it's the exact same work. This has a right triangle with legs of 2 and 1. So you're going to get the same thing. 2 squared plus 1 squared is 4, plus 1 is 5. So square root of 5 is the same thing over there that we get. So these are congruent as well. I guess I could go ahead and mark. That's congruent there. All right. So for the next one then, it asks us to see if we can identify the length of each diagonal. All right, so where are the diagonals? Let me get some blue lines here to mark the diagonals. So if OD is a diagonal, this one's convenient because it's on a nice horizontal line. So 1, 2, 3, 4, 5. So OD equals 5. And the other diagonal here, CL, I need to find the length, and it looks like if I check the X and Y, it looks like 1, 2, 3, 4. 1, 2, 3. Oh, this is convenient as well because that's a 3, 4, 5 right triangle if you remember those Pythagorean triples. Or if you did, change in X is 4, change in Y is 3. So 16 plus 9 is 25 equals 5. So both of these end up getting a length of 5 on there. So these diagonals are congruent on an isosceles trapezoid. So based on the results that we just did, complete the theorem, the diagonals of an isosceles trapezoid are congruent. They are equal to each other. If we wanted to, we could check on other ones, but it's called a theorem for a reason because it's true for all of them. And we could prove this even without numbers by using a couple of triangles here that we know to be true. If it's an isosceles trapezoid, let me mark this one here real quick as well. Then I know that this shared piece here is the same on both of them. The legs, because it's isosceles, are congruent. Because it's an isosceles trapezoid, we've already proven that this angle here would be congruent to this base angle here. So we could actually use side angle side to prove congruency. And once we've proven those two triangles are congruent, any other parts would be congruent. So this long leg here would have to be congruent to this long leg here. So the two diagonals have to be congruent to each other. So without actually going through the proof, because that would take a lot of time, anytime you have an isosceles trapezoid, the diagonals are congruent. Just to be clear, this is not true on all trapezoids. Like this diagonal I'm drawing right now on this trapezoid is not nearly as long as this diagonal. That's only true for isosceles trapezoids. All right. Let's get to some check your understanding in practice. Question number 10, pause here, restart the video in 10 seconds, work on it, then I'll share the answer. For number 10, it says, given quadrilateral PLN is an isosceles trapezoid, use the diagram below and the properties to figure these out. So find the our angle LPN. So LPN, that's this whole thing right here, is congruent to what? Because it's an isosceles trapezoid, I know the base angles are congruent. So the parallel pieces would be the top and the bottom. So on this base, angle P and angle L would be congruent. So we could say PLA. Those would be congruent to each other. All right, if the measure of angle PLA was 70, so this angle we just came up with was 70, then the measure of angle LPN would also be 70 degrees. And the measure of angle PNA, so PNA, A would be this angle here. What would that one be? Well, if this is 70, this also has to be 70 degrees over here. And because these are in between parallel lines, these same side interior angles are going to be supplementary. So 70 plus 110 would equal 180. So 110 degrees. All right, part C says write an equation and solve for x if AP equals x and NL equals 3x minus 8. I'm going to go ahead and get rid of the other stuff. So if AP equals x, NL equals 3x minus 8. So NL, oh, this is just the two diagonals. I know they're going to be equal to each other. So this one's actually really easy. PA equals NL. AP equals, oh, I did PA instead of PA. X equals 3x minus 8. And subtract x from both sides. Add 8 to both sides. Divide by 2, we get x equals 4. All right, so 4 and 12 minus 8 is 4, so they are equal to each other when you plug it back in. All right, same thing with the lesson practice here. Pause. Try these on your own. You could probably do these, even though it's not drawn to scale. Make sure you remember if you need to go back and look at some examples from earlier, you can. But I will have the answers here in just a moment. So pause and restart it in just a moment. All right, now that you've had a chance to try these, let's check our work. So here it says UV is a median, so I know that median cuts through midpoint, so this part is equal, that's a midpoint there. And this part is also equal over here, so clearly not drawn to scale. Now, this is not an isosceles trapezoid, so the total, it doesn't say isosceles, so the total length doesn't have to be equal for both legs. So this side over here is 6, this side's 8, so it's clearly not isosceles, and it doesn't say that it is, even though the picture kind of looks like one. All right, so find QU. QU, 3, that was easy. VS, 4, that was easy. UV is going to be 1/2 of the sum, so UV equals 1/2 of the sum of the two bases, 11 plus 15. So 11 plus 15 is 26. So we get 13, and that is exactly in the middle, 2 units away, 2 units away. Okay, let's look at 12, and now we do have an isosceles trapezoid. So we do know, oh, it's a median as well, so that's convenient. Cuts that in half, and because it's isosceles, this other side is going to be the same. So all 4 of these pieces are actually the exact same. That's probably going to help us out. So let's solve for x first, and then y, and then plug in and get all the rest of these pieces. So x, that's a median, so I'm going to write the trapezoid median theorem. It says that EF equals 1/2 of the sum of the two bases AB plus DC. Plug in, I get 2x equals 1/2 of the sum, 8x minus 43, plus 10. All right, so instead of distributing this 1/2 and getting a decimal here, I'm going to multiply both sides by 2 to cancel out the fraction. Multiply by 2 here, we'll get 4x. Multiply 2 on the right side, it just cancels out the 1/2. So 4x equals 8x minus 43 plus 10 would be minus 33. So now I should be able to subtract 4x from both sides, add 33 to both sides, divide by 4, I get 8 and 1/4. So x equals 8.25. So we can plug it back in and check. Let's go ahead and do that. So 2 times x would be 16.5. 566 minus 43 should be 23. That is right, 23. My bad. So then add these together, you get 33. Half of 33 is 16.5. Okay. So that one did work out for x, 8.25. That was kind of ugly. Let's do y. Well, this one's convenient because all I have to do is set them equal. I know because this is a median, these two pieces are equal, but because it's isosceles, the other side has to be the same two pieces. So each one of those is congruent. So 2y plus 3 equals 6y minus 1. Subtract 2y from both sides. Add 1. So y equals 1. So 5 and 5, those pieces are congruent. So then I get, for my answers here, I'll do it in a different color. I get 5, 5, 5, 5 for each one of these. So AE would be 5, ED is 5, BF is 5, FC is 5, AB is 23, and EF was 16.5. All right. Hey, great work if you got these answers before I did. I know that decimal might have thrown some of you guys off, but you obviously could check your work by plugging back in like I did. Hopefully this wasn't overwhelming because we got 2 more activities, 2 more lessons from activity 15 to learn about some more quadrilaterals. This is another thing you might want to jump on the homework now to make sure it's solidified. There's some additional questions other than what's listed on the homework page. I will see you guys for the next lesson.